Hello, everybody. You're welcome once again to the platform of Altedemy. Today, I have come up with a very important tool in organic chemistry, and that we call this as inductive effect. I hope you must be familiar with the things associated with it. Before I start with the spell on inductive effect, I would like to know about a couple of things from you. The first thing is, are you ready with Altedemy to understand the effects of inductive effect? We need to know about the quality of broadcast. Are you finding it all right with the quality of broadcast on the scale of 1 to 10? How do you rate the quality of broadcast? I hope you must be finding it fantastic. Okay. It is very much customary to ask about the preparation state of your examination, whatever you are preparing. On this, do you think that it is going on wonderfully well? If yes, press 3. Okay. This is your chemistry faculty, and I am Vishwajeet Poddar. I have graduated and post-graduated from University of Delhi, and for past 15 years or so, I am working with various organizations here in Delhi, and have helped many students to clear their JEE and NEET examination with whatever assistance I could provide. Let us see how much assistance can I give you, or how much help of I can be for you. Okay. Let us talk about inductive effect. How do we place this particular concept that we are calling as inductive effect? Some of you might ask, what is the necessity of studying inductive effect? Look here, in organic chemistry, the chapter that we study, we call as a general organic chemistry. In general organic chemistry, we talk about a variety of things, about various kind of effects, and among those effects, inductive is one, hyperconjugation is another, resonance is another, mesomeric again. These are some of the effects that we come across, that we try to find out, that we try to understand. And on the basis of these effects of inductive, hyperconjugation, resonance, and mesomerism, we actually try to find out the stability. We try to assess the reactivity. We try to find out the acidic as well as the basic strength of various substances. This is how we use inductive effect. So, a strong concept of inductive effect is very much necessary. I would like to give you a small formula called as AERHI. You may ask, what is this AERHI? This is the order in which the strength of a particular phenomenon is observed in any chemical process. A stands for aromaticity or aromatic. E stands for equal RS. R stands for resonance. H stands for hyperconjugation. That is what we will be studying in our next session. And the last one is inductive effect. as far as strength is concerned, it is in this order. It is having the maximum strength, then comes equal RS case, then comes resonance, then comes hyperconjugation, and then inductive effect. As a matter of fact, the inductive effect creates the weakest effect. Still, it is very important. Okay. Let us try to understand the concept from the grassroots. Whenever any atom or group is bonded to the carbon chain, then the entire chain becomes partially polarized because of sigma electron transmission. This is called as inductive effect, and it is a permanent effect, and it is always measured with respect to hydrogen atom. I would like to elaborate it. Let us suppose we have a carbon chain, right? We have a carbon chain. Now, here, let us suppose hydrogen is attached. Now, this particular compound will be having some degree of electron density. This compound will be having some amount of electron density. Let us call that this electron density is 1. Let us take the same compound, and instead of H, we put X here. X is also creating or participating, playing some role in creating some kind of electron density. Let us call this density as 2. This density as 2. Or if 1 and 2 is giving you a feeling that 2 is greater than 1, don't do it. Let us stop 1. Let us call this as alpha. Let us call this as beta. Let us take another situation where in the same chain we have Y and we have electron density called as gamma. Right? Now, putting on to the situation, if beta is greater than alpha, then naturally what is happening? The electron density in this carbon chain is being increased because of the presence of X. When electron density is increasing, and how electron density can increase? When this X is sending some kind of electron, which is, and just because there are sigma bondings present here, so there it can happen only through sigma electron transfer. So that means X is sending some kind of charge into this particular carbon chain. We are saying then X is showing positive inductive effect, and we write this as plus I effect. And if we say, on the other hand, that gamma is less than alpha, when gamma is less than alpha, then it is understandable that the electron density in the carbon chain, because of the presence of Y, is less. That means Y is pulling the electrons, and then we can say Y is creating a negative inductive effect. Could you get this? We have two types of phenomena that we have talked. One is a substance which is pulling the electron, another substance which is pushing the electron. The substance or the species which is pushing the electron, we call this having positive inductive effect. A substance or a species which is pulling the electron, we can call this as a negative inductive. Look, why we talk about it. We have all known about the concept of electronegativity, right? We have understood about the concept of electronegativity. What is electronegativity? Electronegativity is the capacity or the capability of a substance to attract the shared pair of electron that we have known, electronegativity. Now, if with a carbon there is a substance, if X is more electronegative than carbon, if X is more electronegative than carbon, then X will create what? Minus I effect. You take another situation. See Y. If Y is less electronegative than C, then Y will be pushing electron. And when it will be pushing electron, it will be creating what? Positive inductive. Wherever we will be getting frequently plus and minus. We will be getting plus I, minus I. We will be getting plus H, minus H. We will be getting plus R, minus R. We will be getting plus M, minus M. Plus is always push. Remember. Plus is always push. Minus is always pull. Right? In all these cases. Because of the electronegativity difference, entire carbon chain is partially polarized. Now, if we are taking electronegativity difference, entire carbon chain is partially polarized. Inductive effect is a field effect. What do we mean by field effect? Suppose you are taking a charge here and imagine the spherical various spheres at different distances from the nuclei, from this charge. As the distance increases, what happens? As the distance increases, intensity of this charge get reduced. So as we increase the distance, effect of charge is reducing, magnitude is becoming less. And that is why inductive effect is distance dependent effect. Right? Okay. In a covalent bond between two atoms having different electronegativity, we call inductive effect as permanent effect. Permanent effect. Why do we call this as a permanent effect? Because some kind of electronegativity will be inherently present. Some kind of electronegativity will be inherently present. And when a substance with a particular kind of electronegativity is present, obviously it will keep on creating its effect. No need for any other substance. So wherever electronegativity difference is present, obviously the concept of inductive effect will be there and it will come naturally. So the same thing has been written in a covalent bond between two atoms having different electronegativities. The electron pair shift towards the more electronegative atom, resulting in the origin of a small fractional charges on the atoms. Let us suppose we are taking a compound CH3CH2Cl. And if we understand that chlorine is more electronegative than CH2, then this is the bond pair which will be slightly shifted towards chlorine. And if it is shifted slightly towards chlorine, that means it will be creating a delta negative charge onto this chlorine. And same magnitude of delta plus will be at this place. And as we have told you that with distance, it gradually diminishes because it's a field effect. So it will be having even smaller positive charge. You should understand this is smaller than this. Magnitude wise, this is smaller. It should not create this confusion that just because there are two delta plus, that will be more. No, no, no. Magnitude wise, delta plus is less than delta plus, right? This induction of polarity in an otherwise non-polar bond due to the presence of an electronegative element is known as inductive effect. I hope some kind of introduction you must have understood. What basically do we want to talk? We will come across organic compounds, and among those organic compounds, rather in those organic compounds, we can frequently find that there are species or atoms which are having different electronegativities. And here there is a word of caution. You should definitely remember the values of electronegativities. I will help you in this session only to remember the electronegativity values of various elements. Let us suppose you should remember the electronegativity of hydrogen. That is very important. It is 2.1. Afterwards, you know, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. These are second period elements, right? Start with 1. Do it 1.5. Do it 2. 2.5. This is 3. This is 3.5. And this is 4.0. Starting with 1, keep on increasing 0.5, 0.5, 0.5, 0.5. You will get the electronegativity of these 7 elements. And again, coming to sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Start with 0.9. Keep on increasing 0.3 only, 1.2, 1.5, 1.8, 2.1, up to this increase 0.3, 0.3. For this increase 0.4, this has become 2.5, and increase 0.5, this is 3.0. At least you should remember the electronegativities of these elements. These are the elements which are frequently used in organic compounds to give you different compounds. So you can understand the difference. Carbon has got electronegativity of 2.5. Rather, we take it as 2.4. So any other compound that you are taking, you should understand what will be the extent of electronegativity difference and what will be the extent of inductive effect. More the electronegativity difference, more is the extent of inductive effect. Okay. Here I just wanted to elaborate you that inductive effect, I effect, is a distance dependent effect. Distance dependent effect. Why are we calling this as a distance dependent effect? Because it is basically related to charge. Related to charge. We have called this as a field effect. And obviously with distance, with increasing distance, the effect of inductive effect gradually diminishes. As you can see here, we had a compound like CH3, CH2, CH2F. Fluorine is much more electronegative. In fact, it's the most electronegative in the entire periodic table. So it will be having a delta negative. Obviously, it will be having delta positive. The magnitude of delta positive and delta negative will be same. In this carbon, on this carbon, there will be still smaller delta delta positive, and this will be again very small delta positive. After third carbon, it vanishes, right? After third carbon it vanishes. So the extent of positive charge onto these three carbons, it can be understood that if we say this is 3, this is 2, this is 1, extent of positive charge, extent, or you say magnitude of positive charge, magnitude of positive charge on 3 is less than 2 is less than 1. Now, what do we do with such kind of information? Suppose we find out, okay, extent of the positive charge is less on the third carbon, extent of positive charge is more at carbon number 2, extent of positive charge is maximum at carbon number 1. What will we do with this kind of information? Anybody to suggest? What are we going to do? Look here, we are reaching to a very important, we can draw a very important conclusion. You know, what is acid? If I ask you what is an acid, you'll say acid is a substance which will donate H plus. Okay, fine. Now imagine the situation, imagine these three carbon. Carbon number 1 is having maximum positive charge. Carbon number 1 is having maximum positive charge. So any H plus associated with this carbon number 1 will be easily repelled. So if I tell you which of the 3, 1, 2 and 3 carbon is maximum acidic, here you can easily say maximum acidic. 1 is maximum acidic followed by 2 and afterwards it is 3. Do you understand what I am trying to say? It is basically, if you find out the extent of charge on a particular carbon, then you can easily find out what are the chances of staying of a positively charged H plus, minimum chance of staying, and the carbon which is having minimum positive charge will have the maximum chance that H plus will keep on staying here. So this way we determine the acidic and the basic properties in a particular compound. Before I move ahead, it is very important for you to know about Altedemy. We have our courses like 90 plus classes, and it is a very convenient educational platform. And the syllabus that we are giving, we are from NEET experts. We are working day and night for you. We have improvised the classroom techniques and we call this as a flipped classroom method. And I'll show you how does it appear, the flipped classroom method. We have the provision of doubt solving practices also. You have your question, we will have the doubt. So such kind of things are also we are dealing with. Okay. This is our class room look like. We have the courses that you will be joining. We will be providing you plenty of theory. Not plenty in the sense that it is irrelevant to you. Relevant theory or study material. Study material comes in a different form. Theory comes in a different form. Two different kind of things that you get. I'm sorry. We have webinars also. We conduct webinars. Webinars for your benefit. Every lesson is followed by a homework. You solve the homework question and you get the correct answer. And there is a homework checking provision also. You'll always be doing like that. We have devised various kinds of plans or programs for you. And these plans and programs can be categorized or has been categorized into three different parts. One is called as light, another is called as a smart, and third is a proficient program. What do we do in different kind of programs? It is quite obvious onto the screen. We have interactive live classes. We have structured courses and PDFs. It is common with all the program. We have live tests. It is common with all the program. We have physical notes. It is with all the programs. Now, in addition to these interactive live classes, structured courses and PDF, live tests and physical notes, we have one-to-one mentorship also. And this is available with a smart and proficient program. We have live doubt solving class also, and that we do with our smart and proficient program. We have regular mock test. Again, that is we are doing with a smart and proficient program. And we have additional special courses that is only available with proficient program. So you can easily understand when you make a comparison that the smart program is really smart. You should choose a smart program on the Altedemy platform to get the maximum benefit for your courses. Again, coming to our inductive effect, there are some common minus I, negative inductive effect showing. By now we have understood we have minus I and plus I groups. Which are cation, which are minus I showing groups? Minus I showing groups. Minus I showing groups, what they will do? They will pull. They will pull the electrons. The cationic group Nr3 plus, OR2 plus, this plus charge will be on oxygen, NF3 plus, positive charge on nitrogen. Cationic groups are minus I. They will always be having a positive charge, so they will be in a position to attract the electrons. All halogens are, minus I showing groups. Groups like OH, NH2, NO2, C triple bond N, C double bond O, COOH, C double bond OR, C double bond OR. Look here. These are some groups which show minus I, negative inductive effect. And there is a very important point that is mentioned here, that minus I power of any cation. Hi Amrish. Hi Amrish. H plus not showed. H plus not showed. H plus is generally considered in what context you are asking about H plus? I could not understand. Inductive effect, H plus. I'm just elaborating. The inductive effect of H is considered to be 0. Inductive effect of H is considered to be 0. Okay. You're welcome. Negative I power of any cation is negative I power of any neutron. It is very important. If there is a cationic species, the minus I power will be greater than that. Minus I power will be greater. I'll give you a comparative list also. Wait for it. Right? Again, we have some plus I showing group. What is this plus I showing group? Plus I groups are those which are pushing the electron. Minus I pulling, plus I groups pushing. We have all anionic group. Let us say CH2. We do like this. We have NH minus, groups like this. We have O minus, such groups which will be having negative charge. these groups will be positive inductive effect, showing it will be positive inductive effect. All alkyl groups, alkyl, generally we represent at R, and CH3, C2H5, these are all alkyl groups. Alkyl groups show positive inductive effect. On third number, we have written a very important point that plus I factor or power is proportional to number of branching at free valent carbon. I'll just explain you what is a free valent carbon. Let us suppose we have a situation like this, and we have a situation like this. Just compare. You can understand this is an organic compound. It is having 5 carbon and there is an X. Let us suppose X is halogen which is attached here. So this particular carbon, it has got one branch here, there is one branch here. This carbon will be called as free valent carbon. Remember it, free valent carbon. Here this carbon is a free valent carbon. On this free valent carbon, there are 3 species which are attached. On this free valent carbon, there are 2 species which are attached. You should always bear in mind, it is immaterial what is the number of carbon that is present, that is not counted in the beginning. Number of branches are counted. Plus I power is proportional to the number of branching at free valent carbon atom. You can easily say, if you say this is compound number 2, compound number 1, then the inductive effect that will be observed in compound number 2 will be greater than the inductive effect that will be having in compound number 1. Right? Even if number of carbon chains are different. Though later we will be studying more number of carbon, more is the inductive effect. But if this is a situation that you are getting 4 or 5 carbon, but comparison is like this, more branching at the free valent carbon, more branching at free valent carbon always gives more extent of inductive effect. And similarly, plus I power of any anion is always greater than plus I of any neutral space. Right? There is some caution also. If number of branching is same, then plus I power is proportional to number of carbon atom. Look here, very important. At free valent carbon, if number of branching is same, then it is depending upon the number of carbon. More number of carbon atom, more plus I effect. As you can see, we have a compound like CH2, CH3. We have CH2, C2H5. We have CH2, C3H7. Now, if we have to compare the extent of inductive effect in these 3 different compounds, then we can apply the extent of inductive effect for 3 is greater than 2 is greater than 1. More number of carbon, more is the inductive effect, provided number of branching is same. Apart from this, I hope you are familiar with the symbol of HDT, hydrogen, deuterium and tritium. These are the isotopes of hydrogen, you know that? Okay. They are all plus I showing group, plus I showing group. And I have written, as Amrish was asking, effect of hydrogen is considered as zero. As far as inductive effect is concerned, every compound, I mean the extent of inductive effect is always compared on the basis of, I mean, taking a reference as hydrogen. So obviously, if we are taking hydrogen as a reference, then the effect of hydrogen is considered as zero. Now, if we compare H, D and T, you should know that the plus I power of tritium is greater than that of deuterium is greater than hydrogen. Positive inductive power of tritium greater than deuterium greater than hydrogen. Hydrogen, we will take it as zero. These are some of the very important points. You should take a note of all those things you will be using when we will be solving the question. Let us talk about one important question. Very, very important question. Look here. If we are talking about minus I effect, if we are talking about minus negative inductive effect, we are taking three compounds like NH3 plus NHR2 plus NHR2 plus, which is more, I mean, all these three species are cationic species having charges onto it, right? So if we try to find out the extent of minus I effect, which of the three will be pulling the electron most effectively? Okay. Now here you can think logically and can say this NH3 plus is not having any alkyl group attached with it. It is having NH, yeah, it should be NH2R. I'm sorry, and this is NHR2. It is having one alkyl group and it is having two alkyl group. An alkyl group, what do they do? Alkyl group pushes the electron. So if alkyl group is pushing the electron, here two alkyl groups are pushing the electron. So the extent of positive charge, it will be having least. So easily you can say that we can have that the extent of minus I effect, NH3 plus is having more inductive effect, minus I effect, in comparison to NH2R plus is having NHR2. Got the point? The concentration of positive charge in NH3 is maximum because there is no species to neutralize it. So we give the minus I order for these three species like this. Now what will happen if there is a species called minus NR3 plus comes? If we have thought the way we have thought here, that 3 alkyl group will be further neutralizing the extent of positive charge, then we should place it here. But actually we notice that the correct order is NR3 plus comes here, then NH3 plus here, then NH2R plus comes, and then NHR2 plus comes here. And it can be understood with the concept of, steric factor. Many of you must have heard about steric factor. I'll elaborate you what happens with steric factor. Steric factor means crowding. Whenever you have observed that there is a steric factor that is coming in between, what this steric factor will do? Steric factor means there will be bond repulsion. There will be bond repulsion. If we understand there is some crowd that has come up, then obviously There will be bond-bond repulsion because everywhere in the bond there is electron involved. So there will be bond-bond repulsion. If the bond-bond repulsion will take place, what generally happens that respective species start getting shrink and the size tries to become small, and we say technically S character increases. And when S character increases, electronegativity increases. Directly saying that steric factor leads to increase in electronegativity will not carry that much of weight, but you should always remember whenever you are talking about steric factor, it goes this way. Some species have come in a small place, they will try to repel each other. When they will try to repel each other, their size will start getting shrink. When their size will start getting shrink, obviously they'll try to become smaller in size. S is comparatively smaller, so their S factor gets increased. When S factor gets increased, then electronegativity increases. So directly we say electronegativity increases. And when the electronegativity increases, then obviously what will happen? It will further add to the concentration of positive charge onto this. And that is why this is the order that takes the place. Well, again the same factor here. Minus I effect of, very important question, minus I effect, you should remember it as a thumb rule. Minus I effect of OH is less than OR. Though minus I effect of SH is greater than SR. Again, it can be explained on the basis of same inductive effect, not inductive effect, steric factors. Steric factor is operational in OR, but it is not operational in SR. Why it is not operational in SR? Because the size of S is very, very greater than oxygen. So steric factor is not playing the role out here, right? This you should remember, the minus I effect of OH is less than that of OR. At any cost, you have to remember this minus I series, increasing, decreasing. Look here, I will write for your convenience, NF3 positive, maximum minus I. Then comes NR3 plus minus I. Then NH3 plus. Then comes NO2, no charge. C triple bond N. Then CHO. Then COOH. Then we have all the halogens, fluorine, chlorine, bromine, iodine, and then OR, and then OH. And afterwards we have C double bond, triple bond CH. Then we have phenyl ring. This is phenyl ring. Then we have a strained ring. Strained ring means cyclopropane ring, cyclobutane ring, cyclopentane ring, whatever it is, like this. And then further we have CH double bond CH2, and finally we have H. It is very important a tool. You should try to concentrate on this tool. Again we have plus I series. You can easily understand what are those. CH2 minus NH minus O minus COO minus 3-degree alkyl. 3-degree alkyl means this is alkyl which is having 3 different carbon attached with it. 3-degree alkyl. Then 2-degree alkyl. 2-degree alkyl will be like this. One hydrogen we will be attaching. Then we have 1-degree alkyl. 1-degree alkyl. Then we have very important a compound SiH3. You might come across some such things. Then we have CT3. Then we have CD3. Then we have CH3. This is 3-degree. This is 2-degree. This is 1-degree, and this is 0-degree. Then we have T, D, and H. Very important, undisputed. Very important and undisputed, plus I and minus I series. Remember it without asking any question. What are the applications of inductive effect? There are 3 applications that we do this. Stability of charges, acidic strength, and basic strength we talk about. Okay. If a comparison is being made and the reference is identical, then its own effect will be 0. These are some axioms that we always follow. And minus I always dominates over plus I. Minus I and plus I, minus I always dominates, right? Okay. Coming to another part, acidic strength is directly proportional to minus I effect. Look here. Suppose we have a compound like COOH, right? We again take COOH and we put 2 different species here. Suppose we put NO2 here and we put F here, NO2 here, F here. Both these species are showing minus I effect. NO2 and F, both are showing minus I effect. If both of them are showing minus I effect, let us try to understand minus I effect of NO2 is greater than minus I effect of F. So if you are asked which of the two is more acidic, easily you can say one is more acidic than 2. One is more acidic than 2. So acidic strength is analyzed with the help of minus I. Minus I always increases the acidity. Basic strength is directly proportional to plus I effect. You might have read or will be studying. Suppose we take 3 species like NH3, CH3, NH2, or we take CH3, N, CH3, H, and we take CH3, N, CH3, CH3. This is 1, this is 2, this is 3, and this is 4. All in a gaseous state. All in gaseous state. If we change the state, things are changing. Now, if all of them are in gaseous state and you are being asked what will be the order of basic strength of these compounds, you know that plus I effect increases basicity. Plus I effect increases basicity. It is easy to understand that 4 is experiencing the maximum positive inductive effect, followed by 3, followed by 2, and then followed by 1. And therefore the basicity order is like this. Stability of carbanion is directly proportional to minus I. Yes. If there is a carbanion, that means carbanion means what? Carbanion is carbon with a negative charge. Carbon with a negative charge. Suppose we have CH, H, H, and again H here. And this bond is broken in a fashion so that this hydrogen leaves its electron to this place. That means it becomes like this. So it is having a negative charge. There is one additional electron that has come, so it is having a negative charge. So if it is having a negative charge, this is called as carbanion. And if you take this kind of carbanion in different manner, then you can say if there is a species which is showing minus I effect, then what it will do, it will create the pulling effect. As I have told you, minus I effect is the pulling effect, plus I is the pushing effect. Always remember. So it will be pulling. So if it is pulling, then obviously the concentration of charge will be reduced. If the concentration of charge will be reduced, then obviously it will become more stable. And this way we explain. An opposite stability of carbocation or free radical is directly proportional to positive inductive effect. Right? Needless to explain it. Distance always dominates over inductive effect. Yes. Distance always dominates over inductive effect. We will elaborate it with a couple of things like this. Weak multigroup shows more inductive power than a single strong group if distance is same. Very important. Suppose we have a compound like this. Suppose we are adding a fluorine here, and again at the third place we are adding 2 iodine here. We know that as far as minus I effect is concerned, fluorine has got greater minus I effect than iodine. But at the same position, if there are 2 weaker groups that are present, then you should always bear in mind that the minus I effect at second will be greater than minus I effect at 1. So in terms of acidic behavior, if you say, you can say 2 is more acidic than first. Weak multigroup shows more inductive power than a single strong group if distance is same. Let us try to solve a question. Find the acidic order of a compound. Acidic strength of a compound. We know that acidic strength will be determined by what? Minus I effect. More the minus I effect, more is the acidity. This is a carboxylic acid and obviously it will be showing acidic behavior. Minus I effect is having a pulling effect. What are the species that are attached? We have fluorine, we have bromine, and we have 2 iodines. Okay. I told you the first things, distance always dominates. What does it mean? Distance always dominates. That means in first and third, inductive effect is greater, minus I effect is greater than what we are having in 2, despite the fact that fluorine is more, having minus I effect. So 1 and 3 is having more minus I effect. So that way, in the second compound, the inductive effect, the minus I effect that is being shown is the least. When minus I effect is being shown as the least, so 2 will be the least acidic. Now, 2 is the least acidic. Look the anomaly. I told you there was a statement about which I had skipped. Distance always dominates over inductive effect. And it means, it carries the same meaning that I am showing you. In first and third, Bromine and iodine are at a located at a smaller distance in comparison to second, when fluorine is located at a larger distance. Distance always dominates. That is why in 1 and 3rd, the effect that is being created is more. Now, among 1 and 3, the another factor that I told you, weak multigroup. Weak multigroup. Here, this is the weak multigroup. Bromine is having more of minus I effect. Iodine is having less. But there are two multigroup at the same position. So in that case, we can say 3 is maximum acidic in comparison to 1, in comparison to 2. This will be the correct order. This is a very important question. Very important question. Try to use it as a theory. This actually is not a question. This is actually a theory. Whatever we have taught in inductive effect, it is a climax of all that question. And you will be applying it elsewhere too. Coming to our program of Altedemy, we will suggest you to join our, Altedemy, Alt-NEET. We will request you to join at Alt-NEET. We have a Telegram channel. You get plenty of PDF material. You get PDF classes. You have many announcements, and we talk about various discounts and prizes onto this. So without wasting much of your time, join our platform to know more about us, to get more from us, right? Subscribe our channel, Altedemy online, to get free classes regularly. We are doing free classes regularly for various for the students residing in various parts of the country. See you soon. Thank you very much for being a patient listener for all those things. Thank you very much. Thank you, Amrish. Thank you all.